Welcome back. This is Mr. Wakefield, and I just flipped over to the last problem in section 5.6. We go on now into part 3 of section 5.6, the part 3 video. And so this is the last problem in the section. Let's take a look at that. It says Seattle Manufacturing Company makes TV monitors. It produces a bargain monitor that sells for $100 profit and a deluxe monitor that sells for $150 profit. Okay. And then it has a bunch of scenarios here. It says on the assembly line, the bargain monitor requires 3 hours. In other words, it's going to take 3 hours to assemble it. Deluxe monitor takes longer, 5 hours. The cabinet shop then needs to get a hold of these monitors, and it takes 1 hour in there to do the cabinet for the bargain monitor, 3 hours on the cabinet for the deluxe. Both models then need to go into the testing and packing department, and both the deluxe and the bargain monitor are going to take 2 hours of time in there. Okay. On a particular production run, the company has available 3,900 work hours on the assembly, 2,100 work hours on the cabinet shop, and 2,200 work hours in testing and packing. How many of each model should it produce to make the maximum profit? Okay. And what is the maximum profit? Answer the first question first, though. Okay. Like I said in the last problem, you can figure out what the maximum is if you know what corner point gives you the maximum. All right. We saw that in the last problem when we found out that the 0 kits and the 4,000 containers of water will help out 40,000 people. So the maximum in that problem, even though they didn't ask for it, if they did ask for it, it would have been the answer would have been 40,000 people. Okay. So first question, as always, when you do a linear programming problem, is what are we trying to find? And use variables to represent that. It says how many of each model should it produce? So what do they mean by model? Okay, they're talking about 2 different models of TV monitor, right? They're talking about the bargain monitors. Let me write that down. And then also the deluxe monitors. Okay. And so let that be your X and Y. You can call it any letter you want. I'll call it X and Y since we're so used to those letters. Step 2. What did we learn for step 2 in the last problem? We learned that for step 2, we need to look at this formula here again. Let me erase off the old problem here so we could start off new. There we go. Again, X and Y, I'll go right here, assuming you're using X and Y as your variables. All right, that hasn't changed. But what is the quantity being maximized? According to the problem, it is the profit, isn't it? So we're going to do profit. So that means that all the red parts represent profit. So what this is saying is it's saying profit per item number 1. What is item number 1 and item number 2 in this case? It is the 2 items that are represented by your variables, just like in the last problem. So the first item, which is X, is going to be the bargain monitors. This one right here is the deluxe. So what this is really saying is it's saying profit per bargain monitor multiplied by the number of bargain monitors. Do we know the profit per every bargain monitor? We sure do. All right. It says right here, a bargain monitor gives you $100 profit. So we're going to put 100 right here. That's the profit per bargain monitor. Okay. Put that plus right there again. Just bring that up. And then here, again, the red thing is profit. So this is the profit per. And then the second item was the deluxe monitors. Okay. So what is the profit per deluxe monitor? It is $150. Okay. And so I'll call this P for profit again. Okay. P stands for profit, just like P stands for people. All right, but you can call it any letter you want. I'll just call it P because it stands for profit. All right, so that is my what I call the objective function. It's the thing that you're trying to maximize. All right. So we'll refer to that at the very end of the problem when we do our corner points, just like we did in problem number 3. Okay, step number 3. All right, remember what we just said just before we jumped back here to number 4. All right, how do we know as we go into step 3 and we do these inequalities, how do we know which numbers are our constraint numbers? As I erase off the old problem here. Remember we said that the numbers that describe the two things that you're trying to find, in this case it's the deluxe monitor and the bargain monitor, those are not the numbers you're constraining. All right, those numbers stay the way they are, but that's not what you're constraining. So notice that $100 and $150, again, that is a description of the bargain and deluxe monitors. Okay, it tells you how much profit you make off of each one. So that can't be one of these green things. Okay, all these things about the hours, they all describe the monitors as well. All right, it tells you how long it takes to do each monitor in each of the 3 different departments: the assembly department, the cabinet department, the testing and packing department. So those numbers can't be one of these numbers on the right-hand side in step 3 here. However, if you go to this sentence right here, what does it say? It says, on a particular production run, the company has available 3,900 work hours on the assembly line. Okay, notice it doesn't mention anything about, it doesn't describe either monitor there. It just says that talking about the assembly line. All right, so it's kind of like the airplane. All right, when we described the airplane in the last problem, there wasn't a mention of kits and containers. All right, it's just describing the airplane's ability. Same thing here. This is describing what the ability of the assembly line is. It's okay. How many work hours can it handle? All right. How many work hours can the cabinet shop handle? 2,100. How many work hours can the testing and packing department handle? 2,200. And so those numbers are the numbers that you want to put on the right-hand side here of this step 3 inequality. It's because they are not describing the items that you're trying to find, the deluxe and bargain monitor, but you can go ahead and double check also just to make sure that it really does make sense that it would be less than or equal to 3,900, for example. And if you see that here, see how it says it has available 3,900. Okay, that doesn't mean you have to use up all 3,900, does it? Okay, that's how much it has available. All right. If I have $100 available to spend this week, it doesn't mean I have to spend all $100, right? Okay, but it means I can't spend more than 100. If 100 is all I got available, I can't go over 100, right? So when you can't go over a number, but you can go less, that means less than or equal to again. Same thing with 2,100. It's the same thing on all 3 of those numbers, the 2,100 and the 2,200 also. They do not, well, we already talked about how they don't describe the monitors, and so that's why we're doing these numbers. But also, it says that that's how much you have available in each one of those 3 departments. Again, that means you can't go over those numbers. You can't go over what's available, but you can go below what's available. All right? And so that's why it makes sense to say less than or equal to. Okay, so let's do one at a time here. The 3,900 was what? That was the assembly hours. Just write that down just so we can follow along more easily. The 2,100 was the cabinet hours. And the testing and packing was the 2,200. Okay, so let's go ahead and fill these things in. Remember, each one's different, so it's going to have different numbers. All right, for the first one, the green is assembly. The green is assembly. And so that means that we go back to the middle part of the problem, and it says quantity per, remember, item number 1 is the bargain monitor. So what it's saying here is it's saying assembly assembly what? I should be even more specific here. It's assembly hours. 3,900 is not just assembly, it's assembly hours. This is cabinet hours, and this is hours here. Okay? So, because of that, the green thing over here and the green thing in the middle, that means assembly hours per bargain monitor. Do we know that? We do. It says here on the assembly line, bargain monitor requires 3 hours. That's the number of assembly hours per bargain monitor. So we put 3 there. Always put the X and Y in the normal place here. Okay, and then bring down the plus. What's the assembly hours per deluxe monitor? It says right here, that is going to be 5. And so we have 3X plus 5Y less than or equal to 3,900. Let's keep going here. We can do that same thing with the other two. For the cabinet hours, it says 1 hour for bargain, 3 hours for the deluxe. And so that's going to be 1X plus 3Y. Okay. Cabinet hours is green this time because that's what you're trying to constrain in this second one. So cabinet hours per bargain, cabinet hours per deluxe. Okay. That tells you that those numbers are 1 and 3 in that sentence right there where it says cabinet shop. In the same way, it says that both models, both the bargain and deluxe, require 2 hours of testing and packing. So that means that we're going to have the same thing, only now it's going to be 2 and 2 along with the X and the Y. Like that. And so there is your 3 bigger inequalities, not including the 2 smaller ones that we always put in every problem, like I mentioned before. I'll put those in there as well here in a second. But let's transfer these 3 inequalities back into on our sheet here, and we get what? We get 3x plus 5y less than or equal to 3,900. 1x plus 3y less than or equal to 2,100. And 2x plus 2y is less than or equal to 2,200. Okay, now remember we also need to have what? We also need to have x greater than or equal to 0 and y greater than or equal to 0. And this right here, you guys, it's a big one. There's 5 parts to it, but that is a system of inequalities that we need to solve. Okay, so it's going to be important to be as neat as ever, you guys. The more inequalities you have, the more neat you need to be, especially when you're trying to find those corner points, which is the intersection points of our final shading that we get. But one thing at a time here. Let's get started here. You don't need, I'm not going to require you to show your work on these 2 right here. It's always going to be the same. Just like in the last problem, when you have x greater than or equal to 0 and y greater than or equal to 0, it's always going to be, these are always going to be the arrows right here to the right of the y-axis and to the above the x-axis. It's going to be that same thing every single time because it's always going to be these same 2 things. All right, so no need to keep on showing your work on that. But these 3 are a different story. They're different than the ones we've seen in the other problems, so we got some work to do on those. Let me go ahead and start out with this one. Again, like always, when we graph an inequality, we change it to an equal sign. We find the intercepts. Okay, again, if you plug in zeros, 0 into x would give me, again, the term disappears, and we just get 5y equal to 3,900. If you divide both sides of the equation by 5, you get 780. Again, I'm just doing the same thing we did in the last problem. When you plug in the intercepts, and it makes the terms disappear that you plugged into, you just have to divide out. Okay, if you plug 0 into the y, the 5y term disappears, and you get 3x equal to 3,900. If you divide both sides by 3 to get x by itself, you get 1,300. Okay, don't graph anything yet. We don't know what kind of scale we're going to use, especially since these numbers are pretty big. Again, you can see that these 2 points, even though we're not going to graph them yet, they're going to be somewhere in these 2 areas here on the x-axis and y-axis. So once again, we can use 0, 0 because we know it's not on the line. As long as it's not on the line, we know we can use that to figure out where the shading is located. I pick what? I pick 0, 0. I plug that into the inequality, and it's going to end up being what? It's going to end up being 0 plus 0 less than or equal to 3,900. And as you know, that means 0 plus 0 is 0, and that's going to be true. Okay, that's going to be true. Okay, I will graph all that information here when it's time. Let's do the other 2 first. Okay, so we can get all of our information first before we all of our points, all of our numbers first before we figure out how to scale this thing out. See how big the numbers have to get. If I plug in zeros here, I get 3y equal to 2100, which is going to be y equal to 700 when you divide out. If I plug in y equal to 0, I get x equal to 2100. No need to divide that time. The x is already by itself. Okay, so once again, these 2 points are not going to give you a line that goes through 0, 0. That means I can use 0, 0 to plug in to my problem once again. And so I pick 0, 0 again. I plug that back into the original inequality, and I get 0 plus 3 times 0 less than or equal to 2100. I think you can see now that we got 0 plus 0, which is equal to 0, and 0 is definitely less than 2100. Okay. And so we'll graph that in just a moment. Let's do the last one here. Okay. How about that one? Sorry about that. That's right here. This one is the one I need to look at now. So let me bring that one down. Change it to an equal sign temporarily. Figure out the intercepts. Plug in the zeros. If you do that and you divide out, you get 1100 on both of these. Okay. Once again, this is not going to be a line that goes through 0, 0, so that means I can use 0, 0 as a way of figuring out where my shading is going to be. In other words, the arrows that I'm going to use to represent the shading. If I plug in 0, 0, just like before, it's going to be true because I get what? I get 0 plus 0, multiply before you add. 0 plus 0 is equal to 0, and 0 is less than or equal to 2200. That is true. Okay. So, with all of this information, okay, let's do one at a time here. I already did the 2 smaller ones as we talked about. We got the arrows there for that. Notice that we've got what numbers? We got 7,800, 1,300, 700, 2,100, and we also got these down here. Why don't we, let's see. Let's do, let's go ahead and do by 200s. By 200s. Okay, we could do that for both x and y. Not that you have to, but so like this would be 200. This would be 400. Again, make sure that they're equally spaced out. 200, 400, 600. And again, of course, the numbers have to be equally spaced out. 200, 400, 600. All of those numbers have a distance of 200 between each other. That's always true. That's got to be done. So the next one would be 800, 1,000, 1,200, 1,400. How far do I need to go? I need to go up to 2,100. So 1,600, 1800, 2000, and then there's 2200. So the 2100 would be halfway between that. Okay, I got a little bit ahead of myself. That's not the first graph we're going to do, but we'll get to it. So that's 2100 right there. I'll just put 2000 next to that just so we can keep track more easily. Okay. But what about the first graph that we did? And by the way, I need to do the y-axis also, excuse me. So there's going to be 200, 400, 600. Let me get this arrow out of the way here. We got enough arrows that we know what direction that's going in. 200, 400, and so on. You just need to, again, you just need to make a couple numbers there so I can see how you're doing your scale. 1,000, 1,200, 14. I don't think we went above, yeah, we didn't go above, actually we didn't even go up above 1,100. So, but that's good. So we'll now be able to fit all of the points on here based on how I scaled it out. The first set of points is 780 and 1,300. 780 on the Y, that is just barely below the 800. Again, get it really close to it. We got to be really exact, okay, on these. So get it really close there. And then 1,300 is going to be, let's count it out, 800, 1,000, 1,200, 1,400. So it's going to be right there. Again, we want to be exact, and we know that 1,300 is exactly halfway between 1,200 and 1,400. So put it halfway in between, and let's graph that line. Again, so important to use your rulers here, okay? So there's that one. What is the shading represented by your arrows? Where is the shading going to go? Again, for all of the ones that I plugged in 0, 0 into, okay, they all pointed towards 0, 0 because they were all true. Okay, so 0, 0 is true each time, so we're always going to point towards 0, 0, all right, on all of these. And so that's why I pointed in that direction. Next one is what? Next one is 700 for Y, 2100 for X. Okay, so 700 is right underneath the 2100. We need to be real careful there, and we will. I'll show you how to make that easier to see here when we draw our graph eventually, or or do our corner points and stuff. But make sure that that's below the 780 though. So when that line crosses through right there, make sure it crosses through below the other one. I know it's real close, but at least make it look like it is. All right, that's why rulers are so helpful here, to be able to do that. Something that would be hard to do is a little bit easier with the ruler. Okay. Again, since all of the points that we plugged in were 0, 0, and since they all were true, all the arrows are going to point towards 0, 0. In other words, they're going to go towards it instead of away from it up above there. Okay, and then the last one was 1,100 and 1,100 down here. So we're going to graph that one. Let's do that. 1,100 was where? That is, let me count it out again. 800, 1,000, 1,100. It's right here. Again, we're getting really close. Everything's getting close together, so we've got to be as exact as we can be. There's 1,100 on the y-axis. That one's not so close to everything, so that's a little bit easier. Okay, let's do that. Let's graph those 2 points. Okay. And again, the arrows go what? They go down towards. Doesn't mean they always go down necessarily, but the point is that they always go towards the point you plugged in if that point is true. If the point was false, then you point away from that point that you plugged in. Okay. Similar to the last problem, you guys. Now that we're have all of our inequalities on there with all the arrows indicating where the shadings are. Similar to the last problem, we have a region here which is the final answer for the inequality shading, all right, that agrees with all the inequalities, and it is this region right here. Don't allow this little tiny triangle to get in there, you guys. That triangle disagrees with the line that's, see this line here that's at the bottom part of that little skinny triangle right there? That line there, the arrows go the other way. So that means that triangle cannot be included. The shading goes away from that triangle for the line that's underneath it there. So don't allow that triangle to be included. Also, there's a little triangle right here. Let me zoom in here so you can see that better. I was referring, let me get this shaded in and then we'll talk, it'll be easier to refer to it. Okay. All right. Okay, so you can see that there's this triangle right here, this open triangle right here. Again, you don't want to shade that one in because it disagrees with this arrow. This arrow, it comes from this line that's to the left of that triangle, and it goes away from that triangle. If an arrow goes away from something, that thing cannot be a part of the final answer. Okay? It has to agree with all of your arrows. The final answer for the shading does. All right? So for the same reason, that's why that little skinny triangle I originally referred to, that can't be in the answer either, because the bottom of the triangle, there's an arrow that goes away from that. So if any side of your little triangle has an arrow connected to it that goes the other direction, then there's no way that triangle can be in there. Now here's where it gets a little bit tough, okay? But we'll get through it, all right? Just listen closely here. Remember we said that after we do our shadings, you guys, we have to what? We have to find the corner points, okay? Now we know that this is a corner point, no doubt about that, 0, 0. Okay. We know that this point right here is a corner point because it's where the end of the shading comes together down here. All right, that's the 1100, 0 point. I'll write that down in a minute. Okay, we know that this point right here is a corner point right there. That's where the line that went through 1100 right here, and the line that went through 1300 over here. I can't tell which line it is yet over here, so let's not look at that. But we know that it's the intersection of this line that went through y equal to 1100, and the intersection of the line that went through x equal to 13. And that I know for sure, so we should definitely refer to things that we're sure about here. So remember, this point is not an intersection point. It is for something else, but not for the shading. And so it's not a corner point of the shading. So don't use this intersection point right here where these two lines intersect, because that's not part of the, that's not on the edge of the shading. It is separate from the edge there, completely separate. It's not along the side edge of the region that I shaded. Now here's, so don't look at that. But there is one other potential intersection here. It's very hard to tell, isn't it? Because it's so close together. Okay, so you might be wondering, well, what do I do then? Well, first of all, we also need to know which, there's another intersection here as well. There's actually going to be two of them, because we know that the shading ends up here somewhere. In fact, you know what? Let's do this. Let me zoom in on that. I'll say zoom in. I'm just going to zoom in on this part right here. Okay, so I'm going to just take that, and it's going to be kind of like when you have your phone and you're zooming in on a picture or something. I'm going to zoom in just on this part right here. Let's bring that down here. If you do that, then I know that there was a point where it crossed through at 700, but there was also another point where it crossed through at 780 somewhere. Okay. And I know that, let's see here. Let me go ahead and draw those first. Okay, so because of the fact that 700 is lower than the 780, Actually, let me draw these first here. Hold on. Okay. If you look at the 780, where did that match up with? The 780 matched up with the 1300, right? But the 700 matched up with 2100. So that makes it clear that these are going to intersect each other somewhere around here. Because down here at the bottom, the 700 actually went further over, didn't it? Okay, it has to go all the way over to 2100 way over here, but the 780 only went over to 1300. So they have to cross paths somewhere. If they don't, then it would the 780 would then have to keep on going past where the 700 went. The point is that since the 780 went to a number that was smaller than what the 700 went to, they have to cross each other in order for the 700 to get to a bigger number. Okay, so we know that there's an intersection there. Okay, we also know that the 700, this line right here, both of these lines, in fact, had arrows like this. So with that in mind, this triangle right here, which is very hard to see up here, that's why I zoomed in, this triangle right here is not going to be shaded. I'm sorry. There it is right there. This triangle right here is not going to be shaded because it disagrees with these arrows right here. So the shading actually starts right here, okay? And it goes down. And then you have the rest of the thing that I showed you at the top. So the point is that we want to know, we already know that this is one of our corner points right here because that's where the shading ends and it doesn't go up to here. But we also know that this is a corner point. Okay. So let's write down our corner points. We'll figure out what this last one is in just a moment, but let's write down our corner points. Our corner points are going to be... Oh, excuse me. I need to make a little bit more room here so that we can write in our answers here. Our corner points are what? They are 0, 0 again. Let's follow it here. And then as we go up, we found out that 700, 0, 700 was the next corner point right there. 0, 700. Okay. We know that 780 is not one because the shading stops right here. And then as we go over here, we'll figure out that one in just a moment. Okay, let me skip that for the moment. We also have this one over here that we also need to figure out. Okay, we'll figure that one out as well. And then this one right here was what? Well, that one I know came, if I follow the line here up to where it's a little bit more clear, it's not, everything's not so bunched together, I can tell that this is 1100 right here. So it must be this point right here, 1100, 0, because it pairs up with 0, 1100, which is this one right here. So that point must be 1100, 0. Okay. Now we need to do that more difficult chore of figuring out what these other 2 points are. This point right here, how do we figure that out? Okay. What 2 points, what we actually mentioned a few minutes ago, but what 2 equations, what 2 lines intersect with at that point right there? It is the, you can tell that it's the point where x is 1100 and the point where x is 1300. So it comes from what 2 equations here? It comes from this one where x is 1300 and it comes from this one where x is 1100. That's how I know. And so let's take these 2 equations and let's solve the system. Let's write that down. 3x plus 5y equal to 3900. 2x plus 2y is equal to 2200. All right. Let's see. I could probably do substitution or elimination method here. I'm going to go ahead and do elimination here. I'm going to multiply. Remember we talked about how you can flip the numbers and then change the sign on one of them. So if I flip the 2 and the 3 here and change the sign on one of them, I can then Multiply those out. What do I get if I do that? I get negative 6x minus 10y, negative 7,800. The other one is 6x plus 6y is equal to 6,600. If I then add the equations together, I get negative 4y is equal to negative 1,200. Okay, and then I solve that equation now that I have a one variable equation. If I divide out the negative 4, I get 300. And then once I figure out what one of the variables is, what do? I then plug it back into any equation that has both variables in it. Okay, I'll pick the first one there. And what answer do I get here? Again, figure out what the term is equal to that you plugged into first. And then if I move over the 1,500 prior to dividing out the 3 there, I get what? I get 800 as my final answer there. So the corner point is going to be 800, 300. 800, 300. Okay. Now let's do the other one. The other one's going to be similar. But there's the corner point there. I put it on the list. And then this corner point is the other one we got to figure out. We can tell right here that this corner point comes from the two lines which had a 780 and a 700. Let's go over here and find out which two lines those are. The one with 780 was the 3x plus 5y equation, and the one with the 700 was this one. So we need to take these two equations and solve that system. Put those two equations together, and let's solve that system here. Let me just bring that over here. So we got 3x plus 5y equal to 3,900, and x plus 5y, pardon me, 3y equal to 2,100. Okay. I'm going to go ahead and do substitution again. Why not? I'll multiply this one by negative 3. Okay, and then add it to the other one. But you could do substitution. Substitution is not that hard on this one. I get negative 3x, distributing the negative 3 through, just like we did in section 5.1 when we were doing the elimination method. I get negative 4y is equal to negative 2,400. So if I divide out the negative 4 now to solve for y, I get positive 600. Calculator will definitely come in handy here on a lot of these things. But if you divide that out, it divides into exactly 600. Then you plug it into any equation that has both variables in it. I'll just pick this one here. And I get x plus 3, plug in the 600 into y, right here, equal to 2,100. Figure out what the term is equal to that you plugged into, and then solve the linear equation like normal. So the final answer on this one would be 300, 600. 300, 600. Let's take that point and let's move that up into our list as well. And those are the 5 corner points of this problem. Okay. All right. So just like we did in the last problem, all right, we take that objective function that was from step 2 and we plug each one of these 5 points into that, and whichever one gives me the biggest p-value is the answer. That's where the answer lies. We know the first one is not going to give us the answer, but I'm going to, just out of habit here, I'm going to plug it in anyway. We know that that's going to be equal to 0. Obviously, that's not going to be the maximum. Next one, we get 100 times 0 plus 150 times 700. That's going to end up being equal to 0 plus 105,000. Again, use your calculator to help you there. The next one is going to be 100 times 1100, plugging in X and Y, plus 150 times 0. So we have 100 times 1100 is going to be equal to 110,000, plus 0 is still 110,000. Almost there. We got 100 times 800 plus 150 times 300. So 100 times 800 is 80,000. 150 times 300 is 45,000. And so that's going to be 125,000. Ooh, that's now in the lead, isn't it? Okay, that's now in the lead. So what do we got here on the last one? Will this take over the lead? We'll see. 100 times 300 plus 150 times 600. Okay, we get what? We get 30,000. Okay, plus 90,000, and oh, it looks like it's going to fall just short here. 120,000. So that means that the previous one right there, the fourth one, that's the one that gives us the biggest P, which is profit. So our maximum profit, you guys, is right here. Okay, because remember, P represents profit. So when they ask, hey, what's the maximum profit? Maximum profit is the 120,000. I know I said we were going to answer the other question first, but we can answer them both at the same time. Maximum profit is $120,000. And remember, when your problem has measurement in it, which this clearly does, okay, hours, dollars, okay, these are all measurement things, okay, words of measurement here, hours, dollars. Our answer needs to have measurement as well, as we've said before with word problems. What is the other question? It said how many of each model? Okay, well, since 800, 300 was what gave you the maximum profit, that's how you answer that question. So 800, since 800 is X, and since X represented the bargain monitors, we're going to say 800 bargain monitors. Okay. And 300 was the Y, and since Y represented deluxe, we're going to say 300 deluxe monitors. Okay, and that is what gives you the maximum profit of $120,000. Okay, so that's how companies can figure out how to maximize their profits based on the constraints that they have. Constraints on the hours that they can spend packing and shipping, packing and testing and cabinetry and assembly and all that stuff. Okay, it's a big problem. Okay, but there'll just be a couple of them in your homework. Don't worry, it won't be like 5 or 6 of them, just a couple. But they are long problems. Be patient. All right, follow what we talked about, and let me go ahead and show you the 2 homework problems just to give you an idea of how similar they are. All right, I know some of you might be concerned about how they're going to be. You can see here number 85 is very similar to the kit and container problem that we did number 3 in the worksheet. All right, where instead of having kits and containers to help out disaster victims, you're going to have cartons of food and cartons of clothing. Very similar problem here, though, okay, where it gives you the volume and the weight of each of the different things, the cartons of food and the cartons of clothing. Number 87 is a little bit different. It looks the same, but it's not. But it's still not way different. Talks about an office manager wants to buy some filing cabinets. Cabinet A costs $10 a piece. Okay, and it tells you, by the way, this right here is area. Whenever they say feet squared or yards squared or inches squared with the 2, the exponent 2, that's a reference to area. Okay, as you already know, this is a reference to volume because it's feet cubed. Okay, Notice that they're talking. What are they asking for in this problem? They're asking for how many of each type of cabinet should you buy. So there's two different types of cabinets, just like there was two things in each of the problems that we did: kits and containers. Okay, deluxe and bargain monitor. Now you have cabinet A, cabinet B, two different things again. All right, all these problems will be like that. So since those are the two things they're asking for, any numbers in this problem that makes a reference or describes in any kind of way the cabinets, that's not what you put on the right-hand side of your constraint here. Okay, so notice that all these numbers here, the 10, the 6, the 8, that describes the first cabinet. The cabinet B is described by $20, 8 square feet. 12 cubic feet. All those numbers describe the cabinets that you're trying to find that's what they ask you for, how many of each type of cabinet. Okay, these numbers, on the other hand, do not describe the cabinets. It describes how much money you can spend. And then here, I know it looks like it's talking about the cabinets, but read it closely. It says there is room for no more than 72 square feet of cabinets. All right, they are not talking about the cabinets there. They're talking about how much room there is for the cabinets. Okay, and so that's why these two numbers right here, the 140 and the 72, they are going to be the numbers that you would put over here. So you'd have less than or equal to 140, less than or equal to 72, that kind of thing. Okay, and notice the 72 is square feet. So that is related to the 6 and the 8, isn't it? That's the reason why 6 and 8 are going to be in the same inequality as the 72 will be in, because they all go together. All right, and the 10, the 20, and the 140, they'll all be in the same inequality as well, going straight across like this, because they are all related to money. All right, so that would make sense as well. And so I just wanted to give you a heads up on that. Do you have any other questions about any of this? And again, I know that they're long problems. Please be patient. But if you have any questions, as usual, let me know. And that concludes Section 5.6. We'll see you next time for Section 5.7. And you enjoy your day.